Okay. Alright, I've been having the worst technology luck today, so if it glitches often, I'm gonna have to do as best as we can. Alright, go ahead and open your notes today, 3 P's. Look like this. Alright, quiet please. Raise your hand if the word supplementary sounds familiar. Complementary, vertical, adjacent. That's what we're learning in this lesson. We're talking about vertical angles and their measures, complementary angles, supplementary angles, adjacent angles, all those different kinds of angles. First, we're going to do some definition work, illustrations, and then we're going to work on identifying those types of angle relationships. Guys. And then after we talk about identifying, because that's the most crucial skill in this lesson, if you can't do the little bottom section of the first page, you will not be able to do the next two, right? So first of all, what do you guys think this definition is referring to? Two angles that share a vertex and a side but don't overlap. Adjacent angles. Adjacent angles, right? Now what's important about this definition is that they share a vertex and a side, but they don't overlap. So if you were to draw adjacent angles, they have this in common, right? But you have two angles next to each other, right? So this angle right here, I'm going to call this angle 1 and this angle 2. Angle 1 and angle 2 are adjacent, right? That line in the middle is the one that they have in common, and then they come from the same vertex. Do we know anything about their measures currently? No. Just knowing that they're adjacent doesn't tell you anything about their measures. The other ones we're going to talk about, like vertical and supplementary and complementary, those actually have an implication with their measures. All right, what about two angles that share a vertex and are opposite each other? Those are vertical angles. When you guys hear the word vertical, what does that normally make you think of? Up and down. That's not what it means in this context, right? Vertical angles, when you guys have two lines that are crossing like this, when you have two lines that, I like to call it the bow tie rule, because when you have vertical angles, you have crossing lines, and then we know that their measures are congruent. Hopefully you guys remember that from when you first learned about vertical angles. If you have vertical angles are congruent. So I like to draw these little dashes, and it looks like a little bow tie. Right? So vertical angles, you have to have crisscrossing lines to create that X kind of shape, and they're across from each other. That's what opposite means. Opposite is another word for across. So these two angles are vertical. Are there any other vertical angles in this picture? These ones as well. Right? There are two pairs per intersecting lines, so you just look, see which ones are opposite one another, and you know that they're vertical. And again, put that little congruent symbol in the corner so you remember that their measures are the same. All right, two individual angles whose measures add up to 90 degrees. Complementary. Complementary. It's a big word for such a small box. All right, so complementary, the key idea there is you need to remember it's 90, guys. Two angles add up to 90 degrees. We're going to draw an illustration over here. I have two angles. All right. As long as the two angles that you have add up to 90, they're considered complementary. So what are two measures I could have, please? 80 and 10. What are some others? 60 and 30, 30 and 60, 45 and 45, 15 and 75. Yeah. So as long as you have two angle measures that add to 90, they are considered complementary. Notice how they're not touching. Are these two angles adjacent? No. Do angles have to be adjacent to be complementary? No. The only definition is that they have to add up to 90. Can they be adjacent? Yes, but they don't have to be. As long as they add up to 90, they're considered complementary. All right, what do you call angles add up to 180? Those are your supplementary. Sorry for my handwriting being okay. All right, so supplementary angles are the ones that add up to 180. So you can draw an illustration of those as well. I want you guys to draw one obtuse angle and then one acute angle with arrows. Oops, oh man, not already. All right, what are some measures for these angles that would make them supplementary? 100 and 80. All right, those add to 180. Are there others? 90 and 90. You could have two right angles. 120 and 60, 140 and 40, stuff like that. So as long as your two angles add to get 180, you have supplementary. Again, do they have to be adjacent? No. All right, I'm going to go back to complementary because I forgot to mention something really quick. This word complement, as well as the word supplement. This is very important for you guys to understand this vocabulary because they could ask you a word problem related to complementary angles. When I'm referring to the complement, that's the second angle of the pair that gets you to 90 degrees or 180 degrees. So they're always coming in pairs, right? Complementary angles have to come in pairs. So if I have a pair of angles and I know one of them is 10, and ask you what the complement of that 10-degree angle would be, what would your answer be? 80. The complement is whatever else you need to get to 90. So if you have a 50-degree angle, what's the complement? 40. So you're trying to get to 90. If you have an angle that is 5 degrees, what's the complement of 5 degrees? 85. All right. What was your supplement? It's the same thing. If you have an angle, the supplement of that angle is whatever you need to continue getting to 180. So if I have a 10-degree angle, what's the supplement? 170. So make sure you're reading carefully to decide if it's the complement or the supplement. But it's basically the missing piece that gets you to either 90 or 180 based on the word. Ishan. Does everybody understand the difference between complement and supplement and how to use them? Okay. What about this next one? A ray or a line segment that divides an angle into two equal parts. And that ray or segment has to start at the vertex of the angle. Right. Angle bisector. Oops, that's I got a T. All right, so the angle bisector, if you guys want to draw an illustration, I'm going to make it a little bit darker. This thing that's going through the middle of the angle, that's the angle bisector. Now, how would I illustrate into this picture that it is bisecting the angle? Do you guys remember? Arches. The little arches. So whenever you guys see that you're using an angle bisector, you need to include the arcs in the diagram. Otherwise, you're going to lose that information and forget that you have two congruent parts. It'll make the solving process much more difficult if you don't have that in the picture. All right, so you have two congruent angles when you bisect an angle. All right, what about two adjacent angles that form a straight line? A linear pair. Okay, now the way that you're going to draw that is like this. Okay, two angles that when you put them together, they are a straight line. Right, two adjacent angles that form a straight line. These angles that form a linear pair are also supplementary. Why would they be supplementary if they're a linear pair? Because a straight line is 180 degrees, correct? And that was the definition of supplementary. So here's something you guys need to be clear on. A linear pair, okay, two angles that are a linear pair, are also supplementary by definition. However, are supplementary angles a linear pair by definition? No. Why not? Because supplementary angles do not have to be adjacent, but a linear pair does. Do you guys understand the difference? Supplementary do not have to be touching, linear paired angles have to be touching, right? So by definition, linear pair is supplementary because they add to 180, but it doesn't go the other way around. If they're 180, they don't have to be adjacent. So that might be something you want to keep in the back of your book. All right, this section right here is the most crucial section of this lesson, right? Looking at a picture and being able to tell me what relationship the angles have. based on what we have up here. You're adjacent, complementary, supplementary, or vertical. Just by looking at the picture, figuring that out. There could be more than one. Okay, so for this activity, we're going to look at the picture and decide all of the different relationships that they have. So let's look at 1 and 2. Angle 1 and angle 2. What's the relationship that they have? Yes. They are supplementary. We're going to abbreviate, as is true for mathematicians, we abbreviate everything. So 1 and 2 are supplementary because they add up to 180. Okay, what else? Yes. They are a linear pair. All right, also because of that they create a line, or that 180 degrees. There's one more. Nothing. They are adjacent. Right? So because they are right next to each other, they're sharing that side, they're right up against each other, that qualifies them to be adjacent. All right, what about 3 and 4? There, 3 and 4 are adjacent. Is there any other relationship? Yes. Okay, why do we know that? The little box, what does that mean? 90 degrees. So the 2 angles that create that box are 3 and 4, so that means they are 90 degrees. Makes them complementary. Is there anything else I know about those angles? Can they be complementary and supplementary? No. Can they be adjacent and vertical? No. So one or the other, or neither. Okay? All right, what about 4 and 5? Yes, Dan. They are adjacent. 4 and 5 are adjacent. Anything else? Can you say that 4 and 5 are supplementary? No. Which also rules out. No. If they're not supplementary, they can't be linear pair. So we can cross those out. So then our only other option would be vertical or complementary. Are they vertical? No. Do we have any proof that they are complementary? No. So we have to stop at adjacent. We don't have proof in the picture to say that they're complementary. All right, what about 1 and 3? 1 and 3 are vertical. I'm going to have to separate you guys. And when we come next class, you guys can't sit next to each other anymore. Dante and Eugene. All right, they're vertical angles. Huh? Okay, well, whatever, that corner, I don't like you guys, how you're not focusing. Daniel, do you have a question or an answer?
Linear pair.
1 and 2?
3.
Oh, sorry, 1 and 3? Why would 1 and 3 be a linear pair?
Because 1 is 180 degrees, is a straight line.
Angle 1 is referring to this angle right here. Okay, when you guys are naming angles with numbers, the angle that they're referring to, the number is tucked into the vertex. So angle 1 is right there, and angle 3 is right here. We don't know what their measures are, so we can't say that they're a linear pair. Okay, they're too small. 2 acute angles can't add to get a straight line. So we know that they're not a linear pair, which also rules out supplementary. Do we have any proof that they're complementary? No. Can I say that they're adjacent? No. Vertical and adjacent are exclusively separated, right? They can't be both vertical and adjacent, because vertical means they're across from each other and not touching, only at the vertex. Adjacent means that they are right next to each other. Okay, so this one's only vertical. All right, what about 5 and 6? They are adjacent. Is there anything else?
Complementary.
Okay, so they are complementary, but I need to have a little bit of proof as to why. Yes, Dan.
Because the 3 and 6, they make a 180 degrees.
Just 3 and just angle 6?
No, 3, 4, 5, 6.
3, 4, 5, 6. All of those angles create this line. Okay? Keep going. There's more that you have to say to get that
Okay,
proof.
well, 3, 4, 5, 6, and you need 90 more to add it up to 180.
Yes. So for 3 and 4, we already had the 90, and if we know that all 4 of them add up to 180, that means they have to be 90 as well. Okay? So anytime you guys have a straight line in one box, there's always a second one. They're not going to draw it, but you can insert it into the picture.
So then would that mean number 3, it would be complementary?
4 and 5? No, not 4 and 5. 5 and 6 are complementary.
I mean,
I don't know about these two.
Oh yeah.
I don't know about 4 and 5, but I know 5 and 6 are. All right, what about 5 and 3? Why? Can we rule out any? What can we rule out? We can rule out adjacent. What else? We can rule out vertical because they're crooked. They're not exact. We're opposite each other. Do we have any proof for supplementary? No, because they're both acute. You can't add acute angles to get 180. Okay, angle bisector is not an angle relationship between pairs of angles. An angle bisector has to be a ray or a segment. That's not what we're talking about right now. Do I have any proof that 3 and 5 are complementary? No, I don't have any proof in the picture using vertical angles or anything. I can't shift anything around. I have no proof for anything, so we would just say this one has none. Well, yeah, no relationships. Okay, is everybody okay with that? Being able to tell what kind of relationships the angles have by looking at the picture? Because if you don't, you can't do the next page. Okay, we're going to start simple. There's like tier 1, tier 2, and then tier 3. And then the next page is tier 4 for you guys. So we're going to start with these pictures. They're real simple. You have one angle given, one that you're looking for. What I want you guys to get into the habit of doing is tell me first what the relationship is. And feel free to abbreviate, but I want you to write down what the relationship is, what you know about their measures, and then give me the final answer. This is important for when we get into proofs. You need to be able to defend your work with a definition or some sort of justification. So, in this picture, what relationship would I use? Okay, so we're going to write vertical, or your abbreviation. Okay, vertical. What do I know about vertical angles? They're the same or congruent, so I'm going to draw a little congruent symbol. So if this angle is 92, what is x? 92. Very good. Well, I try a different color. All right, well, what's the next one? Complementary is the relationship I'm going to be using. What do I know about complementary angles? They add up to 90 degrees. So then I could say x plus 60 equals 90, which would leave what for x? 30. Everybody see how I did that? All right, what about the next one? What relationship would I use? There are two options.
Linear pair.
You could say linear pair. I'm going to call it LP, or supplementary. Okay, what do you know about linear pair and supplementary? Okay, they add to 180 degrees. So I can say x plus 50 equals 180, which means x is 130. Right, this is like your most basic kind of application of these relationships in solving for variables. Okay, here are the word problem type things I was telling you about with the complement and supplement. If I say what is the supplement of a 130 degree angle, how would you find the answer for that? The supplement is what you need to add on to this to get to your full 180. So this is like part plus part equals whole again. If you know part of it and you know the whole split through 180, you can do 180 minus what you know. What does that give you? Okay. So the supplement is 77. In order to get to 180, you have to add a supplement of 77 to the line frame. Does that make sense? Right? This next one's a little bit more complicated. It says the complement of an angle is 3 times as big as the angle itself. What is the angle measure? Okay? When they give you a word problem like this, you're going to need to write an equation. We need a variable. Okay? So I'm going to call the angle x. Right? The angle that we're looking for is x. Right? So how would I represent the complement? The complement of an angle is 3 times as big. So how would I represent 3x? So the complement is 3x, the angle itself is x. So then how would I write an equation? 3x is the complement plus x, which is the other angle, equals 90. Does everybody understand why it's not 3x equals 90? It's 3x plus x. You need the complement and the other angle together because it's always an angle pair. You need both angles working together. So the complement and the original added together gives you 90. Yes, Kate?
I want to say now you're asking 90.
Because this is complement. Complementary are angles that add to 90, so we're using 90 in the situation with complement. Alright, so that's really 4x equals 90 if you combine like terms. And then when you divide by 4, I believe you get 22.5. And if you want to check your work, if you want to double check to make sure you did it right, how could you do that? Plug it in. If you know that the angle is 22.5, the complement of that would be whatever 90 minus 22.5 is, and if you divide that by 3, you better get 22.5 back. Alright, so there are ways you can go forwards and backwards to check your work. Does that make sense? Alright, this is tier 2. Alright, this example right here. This is adding a couple more lines into the diagrams, making sure you're paying close attention to what's going on in the directions in the diagram. So we're going to use angle pair relationships, right, complementary, supplementary, or vertical, to find the missing angle measures. This is very important. This next thing. Make sure you guys are reading all the directions all the way through, because they will have vital information kind of embedded in the directions. That's supposed to say ray, by the way. That was my mistake. Ray RC is an angle bisector of angle BRS. How is that significant? Yes.
Because it's in the middle.
What's in the middle?
RC is in the middle between B and S.
Okay.
So it's like
Okay. So an angle bisector means that the two angles are congruent. Whenever you see that, always put that into the diagram. Illustrate that. So is there anything I could maybe add to the picture numerically that might be helpful? Yeah.
vertical,
Here. So what can I put in this angle? Okay. We're just adding stuff to the diagram now, because if you add information to the diagram first and then go to the questions, it'll be easier to access that information than trying to do it at the same time. All right, so here I have vertical angles. So we have 30 and 30 because they're vertical angles. What about this one? What do I know about this angle? They're equal, aren't they? So what can I write here? Another 30. Okay? Let's go ahead and look at the questions now. I'm looking for EAF, the measure of angle EAF, which is right here. Again, what relationship would I use?
Complementary.
Complementary, which is referring to what in terms of measures? What do we know about complementary angles? They add up to 90. I'm just going to remind myself by writing that. So I know that the 42 and the x together should be 90, so I can write that as an equation. X plus 42 equals 90. Oops. Which means to solve that, I would do what? Subtract 42. All right, so what am I left with? 48. Very good. All right, angle BRC. What's the measure of BRC? 30. We already found that. We use the angle bisector. Angle bisector. Next to each question, I'm going to write why we know that's the answer. Okay? I know this because it's complementary. I know this because we have the angle bisector. How do I find HRT? We found that already when we were just looking at the diagram. How big is it? It's 30. Now, what rule or property did that use? Vertical angles. Okay. What about angle SRT? That's this guy right here. It is 150. Why?
30. Wait, that's equal 180.
Okay, because of what? Property or relationship?
Supplement.
Okay, so there are supplementary or linear pair. Oops. Oops, my goodness. Linear pair or supplementary works. You guys can take a piece of paper or your hand and you can cover parts of the diagram that you don't want. So if I cover this part, you guys, if I cover this part, do you guys see how that's a straight line? H to S. This is a straight line. I know that the 30 I already had, and this angle should be a straight line, which is 180. Or you could use this straight line, right? Whatever straight line you guys see in your diagram, you can isolate that information to find a linear pair. So I know that this is going to be 150. Because 180 minus 30 gives you the 150. Is everybody okay with those examples? Alright, we're going to do the exact same thing, but I'm going to throw some variables in the mix. Same stuff. Same types of relationships, same types of equations. The only thing that's different is that now we're using variables. Your equations are going to look a little bit longer, but we work with them the same way. So, before we get started, everybody label angle 3, angle 4, and angle 5 in your diagram, please. Just write the information in. Alright, our first job is to find x. What two angles could I use to do that? Angle 4 and angle 5? Okay? Yes? I can use angle 4 and angle 5. Could I use angle 3 and angle 4?
Yes.
No.
How?
Wait,
Well, you could-
so you could have to use.
How could I use angle 3 and angle 4?
You could add 4x plus 13 and 6x minus 24 equal to 9.
No, you cannot. Why can you not?
It doesn't state that it's 90
It
degrees.
doesn't state that it's 90 degrees in there. Do you see a box in the corner? Remember, I warned you guys when we were defining right angle in lesson 1, I said you cannot assume that it's 90 unless you see that box. So no, you cannot use 3 and 4. Okay? Very, very dangerous kind of trap that they lay for you. Cannot use complementary. But I can use 5 and 4. What relationship do 5 and 4 have? Supplementary. So I'm going to use supplementary angles between angle 4 and angle 5. They create a straight line, which is 180. Like this. Ooh. I take both angles, angle 4 and angle 5. I add them together and I get 180. Alright, doing some mental math, you get 21x. I think this is like 210 or something when you add those and then move them over. Alright. Okay, and then when you divide, you get 10. So, when you guys do your algebra, you should get 10 after you solve that equation. Alright, now how would I find angle 1? I don't have anything labeled. Yes, Daniel.
You could use vertical angles.
Okay.
For
Good. I know that angle 1 and angle 4 are going to be the same because they are vertical. So even though they didn't specifically tell me what angle 1 is, I can shift the information from angle 4 down because they're the same. And then how would I actually find the measure of angle 1 though? How would I actually find the numbers? Plug in the value of that, so 10. So you do 6 times 10 is 60, 60 minus 24 is 30, yeah, 36. Alright? Make sense? What about angle 3? We have something in angle 3, so real easy. You just plug it in. So 4 times 10 plus 14, that's 40 plus 14 is 54. With this information, what can you conclude now about angle 3 and angle 4? Yeah?
Hold on.
All we did to find angle 3 is plug x in.
Alright.
Okay? So now when you guys look at the picture, angle 4 is the same as angle 1. Angle 4 is 36 and angle 3 is 54. Were they actually complementary? Turns out that they were, but could I assume that they were at the beginning? No. It may be true later on you find that they are, but you still can't assume that they are at the beginning without the 90-degree box. All right, last one, angle 2. How do I find that?
Add 36, 54.
Okay.
Subtract it by 180.
All right, we know this is 54. We know this is 36, or they're both 90 together. Don't 2, 3, and 4 make a straight line? You guys see that? Always be looking for straight lines. If you guys are desperate and don't know where to go, look for straight lines. Usually they're kind of the hidden magic step that you would need. So let's start right here. If you subtract that 90 away, what does that leave you for 2? 90 degrees. So you can do 180 minus 90, which is the combination of 3 and 4. All right? Questions on this? Okay, moving right on. I'm going to keep going unless you guys stop me. So I'm going to let you guys do this one on your own with one tip before you get started. When you guys have multiple variables, this one has A's and B's, and you guys are trying to find a particular variable, only use angles that have that variable in it. What are you doing? Sorry, let me get back to the picture. If you guys are solving for a variable, only use angles that have that particular variable. Hold on. Why? So for example, if you guys are looking for A, you can use this angle, or this angle, but you shouldn't use the ones that have B's, right? But should you try to use all 3 angles at the same time? How many angles are we using at a time? 2. Okay? So I'm going to let you guys try this one. Try to solve for A and B. Only use 2 angles at a time. Look for those angle pair relationships, write equations, and do all the work. I'll walk around and help those of you who need extra support. I'll put the answers up so you guys can check to see if you get it right. Okay? Give me 1 second to do that. I'm just going to write them up now, and then you guys can check as you are working to see if you get them correct.
I really need to put out my like I think she meant dedication.
So 180 minus.
So what you can do is, what is that?
If you go the other way,
So, okay, so you do this. So if you find that you have this function, you plug in A over there, and you figure out that position is 47. Like, when you just subtract 47 from 90, and you find out that this angle equals 43. So to find Y, you just put 7 minus 13.
that's because you have a scalar. If they don't have a line here, Oh, this is all. It's you have the 90 degrees. If it has anything to do with like triangles that have B, you're not, they don't have really oh yeah.
So, you know that this is also going to be wide, like, these are all, these are so 2x equals
You just saw that.
like 7b minus 1.
All right, everybody pause for a second. Pause for a second. All right. I want to make sure we get to the next page because that page is very important for you guys specifically in honors related to your test and your quiz. So I'm going to go through this really quickly, and if we have more time, I can come back and explain anything if it's not clear enough. So for A, you have to use two angles that have a relationship that have the actual variable in it. So can I use this angle? This angle doesn't have a relationship. Guys, focus with me, please. Hello, back corner. Hi. Okay. We can't use this angle. What's the relationship between these two? Supplementary. So you would say 10a plus 13 plus 4a minus 1 equals 180. And you would solve from there. That gives you your 12. All right? You say that those two angles are supplementary and go from there. The two angles that have B, this one and this one, is there a relationship between those two angles? No. So can I do anything with those two angles? Can I combine them in any way? No. So what you have to do to find B is use A. You have to use A to help you. You're going to plug A into one of the angles, like this one, for example. These two angles are complementary, right? But in order to find this one, you plug A in. I think it gives you like 47. When you plug in A, it gives you 47 for this angle, and then you can use that to find B. So sometimes you have to back up, use a previous question to answer the next question, okay? So to find B, you need to use A. Then for these ones, real simple, just plug A and B into whatever angles you need to find those. Yes? Make sense? You may need to use vertical angles to shift angles around, but ultimately you just plug in and use supplementary or complementary or just straight up plug in. Is everybody good for those? Or good with those for now? All right. Next page. I'm going to skip this diagram for a second. I'm going to go down and do these and then wrap back around to this one. I want to talk about these. All right. You will be seeing these on your test, so I want to make sure that they are clear and how to approach them. What do you notice about the labels? Yeah, some of them have two variables already linked together. I told you in the previous example not to mix your variables if you can avoid it, but if they're already mixing the variables and you can't avoid it, then you have to move forward using systems. We practiced that on the first day of school. So systems come in here, right? We still have to use relationships like vertical and supplementary or complementary, but we're going to be using them in the context of systems. So in this angle diagram here, what's one relationship that I could use? Yes. So these two angles right here, you can say that these two angles create a straight line. You can say they're supplementary. So we could say 8x plus 4x plus 7y equals 100 and 80. Everybody see how I got that? No? These two angles right here. 8x plus this one. They create a straight line. So you just write it out like they're supplementary.
Oh, okay.
You could also choose those two angles, whichever angles make a straight line. Perfectly up, it's up to you. All right. I need another relationship now. Yes.
4x plus 7y, the blank angle, they're vertical.
Okay, but we don't have anything written in the blank angle, so that's no. I just, based off the information that's given, I want to write another equation. I want to write an equation now. Yes? Okay. Okay, why would these be equal? They're vertical. All right. There are a couple different ways you guys can create the system for yourself. You could use two supplementary relationships, these two and these two, right? You could use one supplementary and one vertical. It just depends on what's in the picture. You're going to get the same answer regardless of what system you set up, as long as your equations are correct. So in our situation here, we chose one supplementary group and one vertical group, right? Now to solve a system, you need all the variables on one side and the numbers on the other. So we're going to need to use some shifting. This first equation, how can I neaten that up? Combine my terms. So this first equation is going to become 12x plus 7y. Okay, well. Changing colors again. Okay, hold on 1 second. Erase that, try it again. 12x plus 7y equals 180. All right, how can I adjust the second equation?
Add the 8x to the other side.
We want the variables on the left. We're going to subtract the 2x. We want the variables on the left, so we're going to subtract the 2x over to get 6x over here. And then we also want the y's on this side too. So I'm going to subtract the 4y over. What does that leave me on the right side?
Zero.
A 0. Okay. Now, at this point, you guys are going to try to cancel out a variable. Which variable would you guys like to cancel out? The x? All right. Right now, we can't do that. In order to cancel out the x's, they need to be the same coefficient but opposite signs. Right now, it's positive 12 and positive 6. How do I take care of this dilemma? Yes. Multiply the bottom by -2. I'm going to cross this out. And underneath it, I'm going to write the new equation that I actually want. If I multiply this by -2, I get negative 12x. Well, I would if this would be still. That was a negative before, right? I kind of drew through it. Is it negative? Okay. Plus 8. Is that correct? All right. Does everybody see where we are? Okay. Now what do I do?
Now you can cancel out the x.
Now you can cancel them out. Yay. Goodbye, X's. Well, not yay. Well, hold on. All right. All right. They're gone. Now what? Add the y's together. 7y plus 8y. Okay, so 15y is equal to 180. Divide 180 by 15. Y equals 12. So now we have our first variable. Yes? Now how do I find the x?
Plug in the one.
Plug in the y. So whichever equation you guys like most, doesn't really matter. I like this one. I like this one. So if I'm going to plug the y in, right, 4 times y is 48. Before we wrote that, I'm going to rewrite this at 6x equals 4y. You just want to neaten it up a little bit. So if I plug in the y, I would get 6x equals 48. What's 48 divided by 6?
8.
What's it? 8. So x is equal to 8. Alright, everybody with me there?
Wait,
Yes.
I don't know if I got any,
Did you get y equals 12?
yeah, but I got x equals 7.
Okay, so which equation did you plug it into?
I did it to the, 12x plus 7y.
This one? Okay, so then 7 times 12, oh no, that's higher than I ever memorized. Is that 90? 84. 84. So then you would do 180 minus 84 and then divide that by 12.
Okay.
Yeah?
That's I did wrong.
Okay. Any questions on this example? We're going to do another one. So you can see another example. Alright. Everybody look at the one on the right, the one next to it. You have more options. More options in this one. Okay? What's one equation? You need 2 equations. So what's one that I could write? What's one equation that I could write based on this? Lots of options. Ready? No?
8x plus.
Sean, do you have one?
6x plus y plus 9y minus 2x plus 8y minus 2x equals 1.
Okay. So you want to take these 3 right here, add them all together. Okay. Let's go ahead and do that in our head, combining like terms. You guys can do that, right? If I take these 3 angles right here, and I want to combine all the x's. If you combine all the x's, what would you get? 6x minus 2x minus 2x. You get 2x. Right? Then I have y, 9y, and 8y. Okay. So if I take all those angles and add them together, they're a straight line, which is 180. Everybody with me how I got that equation? That little arc I drew, I took all those, added them together. What was I supposed to write? I'm sorry, 18. Yeah. That's my fault. Sorry. All right, what's another equation? Yes.
8y minus 2x equals
Using what relationship? Yes, we have 2 vertical angles in here. This guy and this guy are vertical, so I can set them equal to each other. You guys see that? Okay. Now we have to do our neatening up with algebra. I need the x's and y's on one side, on the left. So the first equation is good. Second equation not so much. How can I fix that? Second equation's not working so much for me, guys. How do I fix it? Move all the terms to one side. So if I do that, I get... Ooh, also make sure the x's are on the left and the y's are on the right. That's also something you want to do. So we're going to switch their positions. Okay? So what would I write first? Yes. Yep. So I'm going to cross that out so I don't accidentally use that again. Does everybody understand how I got that?
Oh wait, I got what?
So what I did, Kaylee, is I took the 2x and I switched their positions. But because it's a negative 2x and I'm subtracting another one. So it becomes negative 4x. And this is a positive 8y and I'm adding up to that. So it becomes 9y. I basically did two things at the same time. I shuffled them and then moved them to one side. All right, now what do I do? Let's see. Okay, so we're going to try to cancel out one of the variables you guys pick as a class. Which one do you want to get rid of? X, all right? If we're going to cancel out X, they need to be the same number but opposite signs. How do I make that happen? Multiply the top by 2. I'm going to reset. Guys, focus. What's my top equation going to be?
4.
And then my second equation, my second equation can stay where it is. What happens? Okay, goodbye. Well, okay, now what? Okay, so 46 plus 9, 55? No? Yes, wait. Is it 55?
Yes, but
No, wait.
It's
45.
Yes, oh, it's 40.
Like what? This is,
Yeah, that's 38.
I don't know why I wrote the 4. Don't worry about it, guys. This is 45. Alright, so we have 45y equals 360. Sorry, that was my bad. I wrote 4 instead of 3. So what's 360 divided by 45? Is it? What is it? So y is 8. Right? And then how do I find x? Plug it back in. So I like this equation right here. Looks real neat and tidy. So if I take the 8 and plug it in, 9 times 8 is 72. And if I subtract that and then divide by -4. You guys can do algebra 1. I know you can do that. So if you plug it in and then solve, what do you get for x? 18. Right? So I know those are a lot of work. Right? I know they are. But you need to be able to use your angle relationships to write equations, 2 separate equations, and then solve using a system. Now what gave away the fact that we needed to use a system? So I want you guys to know when to use a system and when not to use a system. There are 2 variables. If you have 2 variables mixed together in a label, you know you're going to be using the system. If you don't understand what I mean, it's when you see an x and a y or whatever in the same angle, you have to use a system. Okay? We don't have time to do the rest of it. Those are just extra enrichment questions. If you want to try them, you can, but these are really what you need to focus on. Okay? The homework is one side at a time. The next page, one side. Make sure you get it all done and check your answers for me.
Oh.